Let's take a look at how to check the toner add system using the TD or toner density sensor. There are 3 easy steps to this procedure. First, we're going to note the value of VT in SP mode. Next, we're going to perform a forced toner add. And then we're going to go back and note that value of VT, and that voltage should go down a measurable amount. This technique can help you troubleshoot, is the toner attraction pump working? Typical of the MPC 5000, 01, and 02 series of color MFPs. It also works on a black and white machine, typical of the MP 5000 and 01 and 02 series, where you're rotating the toner bottle and adding the toner into the developing assembly. Or even on something like a production color machine, you can see if the sub-hopper is sending toner down to the developer. So let's review how dual component toner works. The term developer refers to toner plus carrier. The toner are small plastic particles, here illustrated in yellow, and the larger blue particle is a carrier particle which is made out of metal. So you've got plastic and metal. So what is the toner density sensor and how does it work? Well, a TD sensor is like a metal detector. It's a coil of some sort mounted underneath the DV or development unit. Here's a picture of one looking underneath the bottom of a DV unit. On this one, the coil is sort of built right onto the board itself, but I've seen them as separate coils. A metal detector. So we can check the output value of that sensor, and it's a form of volts, a couple of volts. The current voltage from the TD sensor called VT, voltage at the TD sensor. Now also on machines, color and black and white, we can force toner into the development. And it usually runs for about 20-25 seconds, and you wouldn't want to do this more than once. But when you force toner into a developing assembly, that voltage should go down. So how does a TD sensor work? Well, VT is the current output voltage of the TD sensor. During the copy process, the toner goes onto the drum and eventually onto the paper, but the carrier stays in the developing assembly. So the plastic goes onto the paper, gets melted with the fuser, and the carrier carries the toner out. So as you use up toner, the developer gets depleted, and the voltage from that TD sensor, VT, rises due to the higher percentage of metal carrier, a metal detector. So as toner is added through the hopper or sub-hopper or however you're adding it on your particular machine, that voltage comes back down. So as you add toner, the voltage of VT goes down. So let's see how this works. So I'm going to enter SP mode using the normal super secret method. And I'm going to go into System SP. SP3210 gives me the current voltage of the TD sensor, VT. I can see my magenta is 1.83 and my K, or black, is 3 volts. So that has more metal than the magenta one. I can also go to SP3050 and I can force toner in by doing a force toner add. So here I'll execute this for the black, the force toner add. Just want to do the one color in this one. And that takes about 25 seconds or so. You'll hear the machine running. So when I go back to SP3210, oh look, it's down to 2.61 volts. That's definitely a measurable difference. So my toner add system is definitely working, and my TD sensor is definitely working. Nice. In conclusion, the TD or toner density sensor measures the ratio of metal carrier to plastic toner. The more toner you have in the developing assembly, the lower the voltage of the TD sensor. The less toner you have, the higher voltage. In SP mode, you can read the current VT for the output of the TD sensor. You can execute a forced toner and VT goes down. This proves that the toner add system is functioning and the TD sensor is working. So you can check all this without taking it apart. Work smarter. I'm John Lewis. Thanks for watching.